So Bill was originally going to give this talk, but a month ago he asked me to do it, and I was more than happy to. I love Node. I love what we're doing with it, so here we go. So the slides and all the links to everything I'm going to cover are available at that link at the bottom, so jsgeek.com/ni. So a little bit of background about who we are at Joyent. We were the original corporate steward for Node, and we've been doing container native. We've just been running containers natively for about a decade now. And you may have heard back in June we were acquired by Samsung, which means now the world's most popular mobile and IoT apps are starting to rely on our cloud. But not super long ago, maybe 7 years ago, we were actually running on Ruby on Rails, and all of the code that managed our cloud was very tightly coupled. And as a result of that, things were difficult to change. So adding new features or fixing bugs was very difficult. And this is due to the fact that what we had actually built back then was a monolith, and it had lots of issues, namely the release cycles were very slow. We had, again, as I said, cascading failures. If you tried to fix a bug, sometimes a new bug would appear, and it was generally just difficult to work with. So back in 2008 and 2009, they started switching over to running JavaScript on the server, and at that time, Node did not exist, so they were running everything with SpiderMonkey, or starting to go that route, and they found that it was perfect for doing async I/O programming, as we all know. But then Node came out, and Node got a little bit more stable, and the people at Joyent saw this and decided to just go full in on Node itself. So we hired Ryan Dowell, the creator of Node, and then Isaac Schluter, who is the NPM creator. And we began migrating that big monolith, Ruby on Rails implementation, over to microservices using Node. And throughout this process, we supported lots of core improvements in Node itself, which I'll talk about. But I went back and I looked at the public announcement on whenever we actually decided to adopt Node, and I found some pretty, well, here, let me read it to you, and you can figure out what you think is about this. Okay. So back then in 2010, Mark Mayo, our CTO at the time, said, "We believe Node is a foundational technology that will enable developers to build the next generation of apps that will finally usher in the Internet of Things era." This was back in 2010. People weren't doing Node. I don't know, it seemed pretty advanced at the time, or pretty insightful. So the other quote in the announcement was, "We knew the async model Node enforced was right, and we knew JavaScript would work too, as we'd already fallen in love with JavaScript outside of the browser, building the Joyent smart platform." So we adopted Node, but it, at the time, lacked a lot of tools that we needed, especially as we were trying to move into more enterprise customers. So one thing that we did was added dtrace probes into Node itself. We also added support for doing postmortem debugging with MDB, which is the modular debugger that comes with SmartOS. And we created and supported the creation of several modules that helped with observability that had dtrace probes built in. So Bunyan, vsync, and Restify. And as we started to just destroy or not destroy, but separate all of our concerns in that monolith, we were implementing microservices. And this aligned very well with our core ethos, which is as a Unix shop, should not surprise you, is the Unix philosophy. And as a result of going the microservices route, all of the components that we built were bounded and were very easy to take down or to add to and iterate quickly. We're able to add new features very simply. And we started to see places that we could actually use Node that probably other people wouldn't expect to find Node. So at the core of the stack that actually does the orchestration for for our cloud. It's called Triton. We have Node Everywhere. So here are some examples of places that we've used Node that you probably wouldn't expect it to be used. So a DNS server, we have it running as our LDAP server. We have it managing all of the NICs on our compute nodes. We even have a key value store that's backed by Postgres. It's all written in Node. And we've learned through this journey that Node is perfect for CLI tools. So the tools that actually talk to Triton and Manta are all done in Node, and pretty much all of our CLI tools are all done in Node. And here are some other ways that or other places that we're using Node. So we have a telemetry agent, we have a DHCP server, and an NFS server. And the point of all this is not to say like, hey, look at all these great places that we were using Node. It's more to get you to think about other places beyond just the API layer or just this orchestration layer between your mobile services and some legacy services that Node actually can work in. So if you look at this architectural diagram of Triton, which as I said is the orchestration stack for managing all the infrastructure in our data centers, you can see all the green are places that are written in Node. So all of those components are Node, which is, as you can see, pretty much everywhere. And that is all open source. So going full in with Node, we already had a value of open sourcing everything we do, but Node especially encourages this. So we have Triton and Manta, and everything else is open source and freely available. And as I said, we were acquired in June by Samsung, and this means that now over 1 billion internet-connected devices that Samsung created are starting to rely on our cloud, which in turn means that they're also relying on Node and Docker as well, and just containers in general. And one of the nice benefits of this is that we've been able to start focusing more on how these three things fit nicely together, and to build out new tooling to help with Node, containers, and microservices. And to walk through one of the solutions that we created, I have this example microservices app. It's a pretty typical Node microservices app using Docker. And if you want to actually see this running, if you come to our booth, I can walk through it with you. But it's simple. It has 3 microservice sensors that are pulling data from a SmartThings hub. So it's reading temperature, humidity, motion, and then it's just throwing those into a serializer microservice that's saved to Influx, and then you have a simple graph display in the front end through WebSockets. And to make all of that possible without the need for a load balancer anywhere, we created something called Container Pilot. So this implements a pattern we call the autopilot pattern, and it means that all of your containers and your apps are self-aware and self-operating, and it has support for console or etcd. You can choose whatever one you want for service discovery, and it works anywhere Docker does. And of course, it's open source and free. So I want to just walk through a quick example of how you would use Container Pilot in Docker. So this is just a Node Docker file. All you need to do is copy over the Container Pilot binary and then pass that in to your command or entry point, because Container Pilot will also act or run as the PID1, which is typically where you'd have your init process running. So it'll reap any zombie processes for you and take care of starting up all of your services. So if you look at the configuration, though, for Container Pilot, it's pretty simple. It's just JSON configuration. You specify if you want to use console or etcd. And then you specify the services that you want Container Pilot to register for you with console or etcd. So in this case, it's registering the front end. And then we have a health check which is all run within the actual container itself, which means you don't have to expose your heartbeat or health endpoints publicly. And then, and I think the really cool part about Container Pilot is this notion that tell me whenever any of my dependencies, any of the services that I care about change. So you say, I care about the backend serializer service, and when that changes, if a new instance comes up or another instance dies, tell me about it. Just send a SIG up to my process. And then that process will know that, hey, I need to go get those new addresses. And whenever you actually run Container Pilot, it's pretty straightforward. Again, you just do your typical Docker Compose workflow, bring it up, and you can scale like your serializer or front-end services as many times as you, into as many instances as you need. In this example, it's just scaling serializer to 2, and since we're using console for discovery, all of the humidity, motion, temperature, and front end are notified that there's another instance of the serializer, and they'll act accordingly. And if you're using Triton, it's very simple to use Docker and to deploy your containers. All you have to do is set your Docker host environment variable to point to one of our data centers, and then you can use that same command, Docker compose up, and bam, you have 5 containers created for you, and any of them that actually required to be exposed publicly get a public IP address, and all of the networking is taken care of for you. Very simple. Another really cool benefit of using Container Pilot is we have Prometheus support built in. So for doing ops reporting, like in this example, where we're reporting on the free memory in the container, it's all built in. So you just add this to your configuration, and then it'll register that with Prometheus for you. So I have a new option now in my dropdown. Tell me the amount of free memory in my front-end containers. And here you can graph that. So you can scale out the number of front-end instances you have. You can drop it back down, and you can see the memory graph. And anything else you really care about your application, you can add to Prometheus. And I just wanted to mention a couple of Node modules that I created to help make this easier. So I have Piloted, which will take care of calling out to console for you, refreshing those addresses whenever your backends change. And it also takes care of doing the load balancing in your app. So it'll actually round robin all of the addresses for you. So in this example, we're saying, give me the serializer addresses for any instance that's healthy. And if you don't have any serializers that are healthy, don't even do anything. Don't try to connect. And then in the next part, we're just using Seneca, which is a microservices toolkit for Node, and creating a connection. So with Container Pilot, there's a lot of great advantages, as I've mentioned. Some of them that I think are notable, though, are the fact that developers can actually move faster. You don't have to worry about calling out to console yourself or managing a load balancer. The microservices that you build out are actually more resilient because of this notion that I am not dependent on a load balancer that I expect to always be there. Now I'm aware of the fact that my application, one of the services in my application could go down at any time, and I built that into how I designed it. And everything is more observable, as I showed with the telemetry example. So in the future, we're, again, investing more heavily into Node itself and containers and microservices. And part of this means that we currently have an open headcount for a core engineer to help contribute back into Node itself. So if you're interested in that, please reach out. And we're doing more work to make Triton itself more observable. So we have this open tracing feature that we're trying to add in. And for everything else that we're doing, including this, we have it all publicly available. So if you go to Joyent on GitHub/RFD, release for discussion, you can find everything that we're planning. Again, the slides are at jsgeek.com/ni, and thanks, y'all.